Peter, good to see you here and having this conversation.
Nice to be here.
And we're talking with Peter Norvig, the Director of Research at Google, and we're having a couple-day conference down here in San Diego on the good ancestor principle, particularly the complexity of good intention. So that's the theme of the workshop. But Peter, tell me a little bit more about your background and how you got into computers and such.
Okay, I guess I got into it because it was always the easiest and most fun thing to do.
You were lazy.
I was lazy, right? I had a little bit of computers in high school. I was just getting started then. And then in college, I was actually an applied math major, but I took the computer courses. Yeah. And I always found that they were easier than the math courses. Yeah.
And so what is your progression in terms of programming and languages that you learned and things like that?
Oh, let's see. I guess it was basic in high school, and then PL1, and assembly language in college were the primary languages. I started to get into AI then, so learned a little Lisp in college. Then graduated and had a professional job, and I guess it was mostly Pascal then was the language, and C was just starting. You know, Unix was just starting getting going. But most of our customers were on CDC machines and VAXs, and weren't doing that yet.
So go ahead.
And then in graduate school, mostly Lisp programming, and then since then I've programmed professionally in I guess first Perl and then Java, and I use Python sometimes now, and some of the sort of proprietary languages for special purpose things.
So where did that take you in your career? What was your career path in all this?
So out of college, I got a programming job at a small software company in Cambridge. I was doing sort of software verification work, and then after 2 years of that, I said, gee, it took me 4 years to get tired of college, only 2 years to get tired of work. Maybe I should go to graduate school.
Okay.
And ended up at Berkeley studying artificial intelligence. From there, I taught at USC, came back to teach at Berkeley, and then went into industry, first with Sun Labs, a couple other companies along the way, and ending up at Google.
And what did you do at Google?
Right now I'm the Director of Research, and previously I was Director of the Search Group.
So can you tell us the secret sauce that Google uses for searching? We won't tell anybody. Okay.
Look at all the factors and try to understand how they're important and combine them together.
But it does get smarter the more people use it.
Yeah, so it's a combination of more people using it. We learn from that. We learn from our own efforts and more experience. And it also gets smarter when there's more content on the web. If people write more good material, then we can find it.
Well, getting back to your history there, I think one of the interesting things that I've noticed in computers is that the genius of the modern computer was the von Neumann architecture that put data and program in the same memory. And so it did this lumping of data and program. And then Fortran and COBOL split them apart, and Lisp kept them together. So the distinctions between these two things aren't the same. And in my own work, I used a language called MUMPS in my hospital work a lot. It wasn't quite Lisp-like, but it was closer to Lisp than Fortran. So when we did the VA hospital information system that's now called Vista, we only used 19 commands and 22 functions for the whole system, and it was just highly reentrant code. And that was written for the PDP-11, then it went to the VAX, to the PC, and all these things. So you only needed to port the small kernel, and everything else went with it. So I think that was a key to the long-term viability of it. But anyway, do you have some observations about symbolic languages versus compiled languages? Have you noticed any difference in the way that people think and work with them? Or?
I think it's good to get a variety of viewpoints. I think there's less of a distinction now than there used to be because the languages are adding features and, you know, seeing what other languages have and putting them together. You know, so when I was in grad school as primarily a Lisp programmer, there were all these library functions and so on that were in Lisp that just weren't in C, was the main competitor there. Yeah. But now, if you compare Lisp to C++, it has plenty of libraries. Java has plenty of libraries, and so on. Yeah. So there's less of a difference. The other thing I see is that language choice, I think, is less important. Nowadays, you're doing less of writing from scratch and more of piecing together components that have already been written. And so it's kind of the glue languages to make them work together. And the kind of the environment as a whole is what's important, and the particular language is not as much.
Yeah. So what do you see in terms of software productivity over the years? I mean, compared to 10 years ago, how much more or less does it cost to do the equivalent functionality?
I guess it depends on what you want to do, right? Yeah. So as I was saying, I think a lot you can do now just much faster because it's already been done. Most of what you want to do, somebody else has already done, so you find the pieces. Yeah. It's easier to find the pieces now. It's easier to put them together. Yeah. There's, for most of the things you want to do, there's less concern about running out of computing resources. Yeah. You know, I mean, I'm sure you were used to saying, you know, we've got to cram out a couple bytes to make it fit into memory. Yeah. People don't worry about that as much anymore. So it's, I think productivity is higher. If you want to do something that's completely new, then I don't think it is. Then I think you're up against human ingenuity, and I don't think that's getting any better. Yeah.
So where is AI today now? What's the state of the art? I know that over the years we've had more than a few false starts about AI was going to solve the world's problems, and they didn't always come true. But where do you think we're going now?
Well, I think AI is solving the world's problems.
Oh, okay.
But you know, as soon as you solve a problem, you don't call it AI anymore. Right?
I see.
Because when you end up deploying it in a real system, it's all the other stuff in the real system becomes you know, what you focus on and where all the work goes to, and the AI just ends up being a small component. Yeah. But you know, we're solving these problems. Chess is a solved problem. Driving cars and traffic is coming along. You know, we haven't yet signed over all our cars for the consumer, but in test cases, you can do a pretty good job. And you know, you see place after place where this is happening. And I think in general, there has been a big push to say that understanding data and doing machine learning and so on is an important approach that you see throughout the industry. And so to some extent that's a success for AI. It's become mainstream, and people don't even think of it as AI anymore. Okay, so it's just part of the foundational approach to things, and so it's not a okay. Well, fortunately, I can edit out my stumblings here. So, reminder to me: edit my mumbling here. So, tell us a little bit about your work with statistical understanding of machine translation. How's that working? That's coming along great. So we have a group at Google working on translation of languages. And it uses a completely statistical approach. And we're doing, I think it's 41 languages now, it might be more. And we can do all pairs. So that's 41 squared, 1,600 and something.
So each language is compared to every other language directly? You don't translate through an intermediate one?
Sometimes we do do through an intermediate, right? So let me explain how it works first, and I'll get back to that. Okay. So we go out and we collect two kinds of data. One is we just collect a lot of text in a language. So we go out and collect a few trillion words of English. And then we make a model of English, saying how likely is this sequence of words in English? You know, of the is very likely. Yeah. Purple Schenectady, less likely. Okay. We just go out and count all these sequences, 1, 2, 3, 4, 5, 6, 7 words in a row. Yeah. So that gives us a model of English, a somewhat impoverished model. It doesn't know everything that there is to know about English, but enough for the purposes. And then we need the bilingual model. So if you want to translate from French into English, we go out and we get a bunch of examples of translations that have been done so far. Say, here's a page in French, here's a page in English. And maybe we get them from the Canadian parliamentary proceedings or the EU proceedings, or maybe from a bilingual newspaper that's published on the web and so on.
Yeah.
We just collect lots of examples. And now we know this article is a translation of this article. And if anybody asks us for the whole article, we can translate it. But of course, they're not going to ask us that.
Yeah.
They're going to ask us a sentence at a time. So then we try to say, well, does this first sentence correspond to this first sentence? Or maybe it's one sentence to two sentences. And we start with a probabilistic model that hasn't committed yet. But as you see more and more examples, you narrow down those possibilities. And now we can actually say this sentence corresponds to this sentence. And within that, we can say this sequence of words corresponds to this sequence of words. And then it's just a process of taking the input for each sequence of words, seeing what other sequence it has been translated into, and then combining them together and using the output model, the model of English, to say what's a good sentence of English.
So you don't have any grammatical understanding what's happening. It's just the statistical replacement.
For the most part, no. And up till this year, there was no grammatical component whatsoever. It was the only grammatical component we had is the notion of a phrase, where a phrase is a sequence of consecutive words.
Yeah.
So we knew phrases, but we didn't know noun phrases or verb phrases. In the last year, we have, all along we've been trying to say, well, probably knowing nouns and verbs, noun phrases and verb phrases should help.
Yeah.
Up to this year, it didn't help. The reason I think it didn't help is because the parsing technology has flaws in it. So it was introducing errors as well as introducing good results. And we think that the good results that it introduced, we already learned just from the model of phrases as sequences of words. Yeah. So it wasn't adding anything. Last year, we've got some better parsing technology, and now for some language pairs, it actually is helping, particularly for ones that have large movements. Yeah. So, in English, the subject comes first, and then the verb, and then the object. In Japanese, the order is switched.
So you do have a manual, a smart person flipping that around?
No, it's not.
No, you're
it's not done by a
these.
person. It's all done by the
software.
So
it's all automated. Okay.
But the software is actually detecting the noun phrases and verb phrases.
So the more input you have to train with, the smarter your system will be. I see.
Right. So.
Well, this gets into an example. I like to talk about the difference between a library for finding things and Google. In a library, you have the building, you have the card catalog and the Dewey Decimal System, and that refers you to the books on the shelves and the chapters and the structure. And the library is only as good as it's organized with the librarians and the Dewey Decimal System. And if you have the wrong organizing system to it, it falls apart. If the librarians don't do it, you get more books, you got to double your budget. So the library gets more expensive the more you use it. And it falls apart if you don't keep it up to date. Google, on the other hand, you search by terms, and it gets smarter the more people use it and the more context it has, and it fuels itself. So libraries I call an entropic system, and Google I call an autocatalytic system. So one of the success factors in Google, I think, is it does fuel itself. And I could write a better search engine maybe today, but Google has all of this horsepower behind it. This already started this bootstrapping process, if you will. I'm just wondering, and I think what your machine translation is another example of this kind of a bootstrapping process. It gets smarter and smarter, and the more material you have, the better it'll get. So what do you see, are there other domains that you could have this kind of autocatalytic bootstrap growth in?
Yeah, I think there's a lot. Let me try to understand your concept better, and maybe you relate it to things I know. So we certainly talk about network effects and how having more makes things better.
By the way, I met Sergey Brin when he was still Sergey, or back at grad school, and I took my notes and I said, Sergey Brin thinks about scale the way that teenagers think about sex, and he used the word scale about every other phrase. Scale, 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 scale. So network effects was certainly his thing. Okay, go ahead.
Right. So, part of Google gets better just because the web gets better. And that's not unique to Google. everybody benefits
Yeah.
from that. Then there is a part of Google that gets better because we have users. So users come in, they click on something, we see what they're doing. When they're not happy, we can correct.
Yeah.
And so that's something where, because obviously we can't share our user data with anybody else because we have
Yeah.
to keep it private, that means that we're benefiting from it and other people are not. So I think that's the distinction. Does the aggregation help anybody to be able to tap into that, or is it concentrating in the sort of the designer of the mechanism?
Yeah.
So something like a social network, like a Facebook. For now, it seems like as you get more friends, Facebook is more valuable, and you gain more by having a larger network, but nobody else really benefits from that. We'll see. There are some movements to try to open things up, to say, well, Facebook wants to be able to collaborate with MySpace and FriendFeed and everything else.
Open up their social network.
Yeah, to have a way to
API.
say, not only can they benefit, but other people can benefit from what they have, and then they can benefit from what other people have.
Yeah.
And so I think that's two different ways to look at these kinds of designs.
Yeah. Well, I think the network effect, obviously the more nodes you have and the more connections they have, the more it will take off. But you can say the libraries have a network effect too. You have an interlibrary loan, and yes, it does work that way, but it costs a lot of money to run interlibrary loans.
Yeah.
It doesn't cost a lot of money for Google to put in a new secret sauce to search in a different way.
Yeah.
So all we're doing is just organizing bits in a different way rather than shipping atoms around or whatever.
Right. So certainly, and I guess I think of that as a separate idea, this idea of being able to iterate quickly and get feedback. So it is very important to us that we can try out a new idea and say, is this new idea better than what we had before? And it's true that by having a lot of users, it makes it easier for us to do that. We can see, does this change make the users happier or less happy?
Yeah. So what do you see happening in search? Do you think they'll have smarter searches so I can search for a price of an airline ticket and have it understand that I'm looking for a price of a ticket, not a Vincent Price movie?
Yeah, I think so. I think a lot of things will be smarter. I mean, things like that are now pretty good, but the way that they're handled now is through intermediaries, right?
Yeah.
So now if you search for airline prices, we'll tell you, oh, Orbitz, that's a good place to do that, and here's 5 other sites from which you can do that. What's harder to do right now is to say, to tell your computer, okay, don't just tell me here's 5 places where I can compare tickets. Do the comparison and show me the results, and book me the best one. And so this kind of going from receiving information towards taking action, I think, is harder. And it's certainly hard to go all the way to have the computer take action on your behalf, because do you really trust your computer with your credit card? I don't know. And it's also just harder to have it aggregate information. So Google relies now quite a bit on the user synthesizing the material that we bring back. And so people are very happy because the results we bring back are relevant, but they still have to read the pages and say, to me, this paragraph is important here from this page, and this other paragraph from this page. We don't put that together for them. And I think you will see search doing a better job of synthesizing results from multiple pages rather than just listing pages.
And what about the semantic web and being smarter on how we put the data out there? Do you think that's a viable approach, or is it?
I think it'll work in some domains and not others. You mentioned this clash of library science versus search as it's come to be today. And of course, search came out of information retrieval, which came out of library science, so they share a common ancestor. But it is quite different. And, there's this question of, do you want to have a controlled vocabulary and everything has to go in its place, versus is everything free form? I think inherently most things are going to be free form. There are going to be some that will be very well handled by structured data, but a lot of it won't. You know,
Yeah.
you look at these books like Everything is Miscellaneous
Yeah.
that talks about this type of problem. And so
Yeah.
I think what you'll see is communities that come together and say, we're going to heavily get into semantic web, and we're going to agree on this ontology, and we're going to share our stuff. And that'll work well when there's a motivated community that can come to that agreement.
Yeah.
So places like in genomics and proteomics today, that's starting to happen. And they really need it because they have this vocabulary problem.
Yeah.
You know, the E. coli guys have a name for a gene, and the mouse guys have a name for a gene, and all of a sudden they discovered it's the same gene, but it has a different name. And so they need a common
Sure.
vocabulary, and they've all agreed that it makes sense for them to share and be non-competitive and come to an agreement. In other domains, people are not going to come to an agreement, right? So if you allow everybody on the web, not just a community that's built itself up, if everybody can put a semantic label on everything, you'll see, oh, well, that's just another good way to spam.
Sure.
Right?
Yeah.
And people will say, here's the exact answer to your semantic query, and you'll click on it, and you'll be offered cheap Viagra.
Yeah, yeah. Okay.
So there's, you know, it's not going to solve all the world's problems, and it's not going to solve the problem of information in general, right? So if you have a well-structured database, yes, it's very good, but I don't think we're ever going to get to the point where the average blogger is going to write a paragraph of free text and then mark that up semantically, because the concepts are just too vague and too varied.
So you see it as very specific domains that would have standards committees that would say tag this way and tag this that way.
Yeah, so I think some of this will be done by standards committees, and some of it will be done just informally. You know, one guy will put out a standard, and everybody else will say, "Yeah, that's good enough. Let's use it." Okay. Tom Gruber says that every semantic ontology is a treaty. A treaty, right? So warring parties have come together and said, you know, we're tired. We don't want to fight anymore. We want to stop the fight. So we're going to agree to call this by this name and call that by this name.
I see.
And you know, you have to have parties come to the table before you can have a treaty.
Don't chop each other's trees down,
right?
Or grow a forest. Well, yeah, that's clearly an issue I've been wrestling with for years on the healthcare field: controlled vocabulary versus free. And well, one other topic: when Google went public, it promised 1% of its income and equity to a nonprofit philanthropic organization. I know you're not directly involved with that, but as an employee, and I know you're interested in philanthropy personally. What do you think, how's Google doing on meeting that promise? Have you thought about that at all? Or?
Yeah, I mean, I haven't run the book, so I don't know. I suspect they're underspending that amount, and I think the reason is they want to be careful what to spend on, and you know, it still feels like it's in the ramp-up period. I like the projects they've chosen. I think they've chosen important areas, and I think they've chosen the right approach at it. Right. So you know, 1% of Google's money is not that much. So you have to be very careful what you try to do and what you try to encourage other people to do.
Yeah, I think Target does 5%, by the way. So you're only 20%. I have run the books, by the way, and you've earned $14 billion since you went public, and 1% of which would be $140 million. And you put $90 million into your nonprofit, which would evaluate it.
So a little over 0.5%.
Yeah. So you're not quite up to speed yet, but I'm sure it'll accelerate with Megan Smith taking over and doing that. So I would encourage you to do that. And I'll continue to blog your progress, by the way. So we'll make sure we have somebody doing the numbers on you here. The other thing I think, and that's what we'll be talking about this week at the workshop, is this model of search amplify as opposed to plan execute models of uplift.
Well, actually, before you get into that, can I respond to one more thing? Is that you know, I'm glad you're doing this and tracking it and keeping us honest, and we should do what we said we should do. On the other hand, you know, I think it's discouraging that people evaluate philanthropic work in particular by amount of money spent.
Right.
And really, you should evaluate it by impact that it has. And you know, I get peeved. There are these sites where you can go and rank charities,
Yeah.
and they rank them by percentage of your dollar that goes,
Yeah.
you know, that eventually makes it to the end user
Yeah.
versus gets siphoned off for advertising, whatever. And that's a good metric to know, but it shouldn't be the only metric.
Right.
And, you know, and if you think about it, if that's all you're going by, then these guys are all losers because they're all less than 100%.
Right.
And if you're an investor, you're not looking for, gee, can I get 95% of my money back versus
Yeah.
85? You're looking, can I get 1,000 versus 5,000?
Sure.
And so really we should be evaluating this work not by what you spend, but by what the impact's going to be.
Well, I agree, and that's been a long topic. It gets back to my insistence that we need a new accounting system, and I put this into the whole notion of trying to break things up into transactions and evaluate them at the time of the transaction, adding them up, and then assuming you get a bottom line. And when that doesn't work, we spring over to another bottom line, so we're at 2 and 3, 4 bottom lines now. The problem isn't that we don't have enough bottom lines. The problem is that we're using bottom line linear thinking in the first place. So what you're talking about in my world, I'd call it transformational thinking rather than transactional thinking. And yes, maybe sending money to the poor people isn't the best way to help them. So we desperately need this. Of course, this is a really hot topic in a lot of philanthropy circles and the social venture capital stuff. So how do you evaluate these things, particularly preventative? So we do something today that prevents an epidemic next year. We don't really know that we didn't have the epidemic. So how do you go back and say it was worth what we did today?
Right.
And this is the key in all of our preventative things. It's really hard to figure out to keep the dikes repaired, but it's real easy to repair them after they break.
I know there's been talk lately of you know, what a failure Gerald Ford was because he vaccinated against swine flu in '76, and you know, it was a waste because nobody died of swine flu, rather than saying he saved hundreds of thousands of lives.
And there's no way you can answer that ever.
You don't know.
So somehow we have to have a way of understanding the future in something other than adding it all up to be the bottom line. And also, the other thing is we can only react to problems. You know, something has to manifest itself as a problem before we react to it. So the dikes break, we fix it. You know, somebody has a brain tumor, we fix the brain tumor. But preventing these things is really difficult in those metrics. So yeah, I agree with that. On the other hand, Google made some pretty specific comments about 1%, and if you interpret those...
We should be kept to that.
And I'm happy to help you decide where to send it if you want. But so anyway, but the other question, I think, is this whole notion of searching at a small granular scale of what's happening in the world and then amplifying the things that are working, rather than having planned interventions that are centrally planned and executed. There's a balance between the two. It's like free text versus coded terms in semantic analysis or whatever. But and doing an epidemic requires central planning, and you don't expect people to invent their own vaccines to solve these things. But on the other hand, I think there's a search component to this that I'd like to talk about this weekend about how do you discover these things rather than how do you plan them? And the same way as you're discovering how languages work from Arabic to English through statistical analysis. So I guess the issue is what kind of space would you have to be searching in to come up with these ideas? I mean, there's lots of things happening in the world there, but how do you get a handle on what's happening in the world that way? You got any ideas on that, or?
I guess you start by thinking what the big problems are, and then think about what could I change for that, and then look around for technologies and social structures that could bring about that change. So I guess one of the examples from Google.org is we said, well, as a company, we should have something involved with energy because it seems like that's an important issue. And Larry Brilliant wanted to have something around energy conservation. And Larry Page says, that'll never work because you can only go so far with conservation. And Larry Page said, well, maybe if you're really good, you can have people conserve 20%. But we have to cut back 80% of our emissions. And so even if you were 100% successful, it wouldn't be enough.
Yeah.
And so instead we came up with saying, rather than the conservation side, let's look at the supply side. And we came up with this renewable energy cheaper than coal, because we said, you know, most of the pollutants are coming out of coal plants.
Yeah.
We have to shut down all the coal plants in order to do that. Well, people still need the power, so you need some alternative. So you need something that's cleaner and cheaper, because if it's not cheaper, they're not going to use it.
Yeah.
So that was the kind of thinking that led us to say that's the right way to go.
So what is that energy now, or what are the candidates for it?
We're looking at a bunch of different things, solar and wind primarily, some tidal as well, some geothermal. On the solar side, we're looking at solar thermal rather than photovoltaic, because we think at large scale that's more promising right now.
Okay, well, thank you very much, Peter. I enjoyed talking to you.
Thank you,
And
Tom.
we've been talking with Peter Norvig, Director of Research at Google, and look forward to checking in with you in a few more years and seeing where AI has gone.
Okay, let's do that.
Okay, thanks a lot.